Good morning, everyone. Good morning, class. Due to the transport strike, we have to conduct these asynchronous classes. So, according to the Department of Education, learning must continue. So, after this discussion lecture, you will have to answer the closure activity exit pass. So, the purpose of that exit pass is if you have some questions, clarifications on today's discussion. Then after this discussion, I will send a seat work quiz through our group chat, and that will be checked once we have our face-to-face modality or classes, hopefully on Monday. Okay? So let's start. The topic for today is mean and variance of random variables. Objectives: at the end of the lesson, you must illustrate the mean and variance of discrete random variable. Number two, you must calculate the mean and the variance of discrete random variables. So, what is mean and variance of discrete random variables? So, by definition, the mean of discrete random variables are also known as the expected value. It is the weighted average of all possible values of the random variable. So, the symbol for this is this, mu. Okay, so this Greek symbol, Greek alphabet, we call it as mu, and this is the symbol for mean. Okay, so mean for population, mean means the average. Okay, so the average of all the data. What is variance? So variance is a measure of spread or dispersion. It measures the variation of the values of a random variable from the mean. So the symbol used for variance is sigma squared. So this symbol is Greek alphabet, small Greek alphabet sigma, and it is squared. And the standard deviation, we must get the standard deviation. How do we get the standard deviation? It is by getting the square root of the variance. Okay? So later we will discuss, we will have a review about variance and standard deviation if you're not familiar with these two terms. So let's review the mean, variance, and standard deviation. Again, mean means it is the average of all the data that was given. So I prepared some data. So this data, again, reminder, this is just a review. This is not the discrete mean of the discrete random variable. And we know that weight is not discrete, right? Weight is continuous data. So I prepared this data or statistics about the sample of the weight of the dogs of a particular clinic. Okay, so veterinary clinic. So here are the data. So here are the weights of the dogs. If you will check the graph, you will just assume the value of the data. It is necessary to have the actual numbers of the data, like this one: 10, 12, 13, 17, 20, and 24. So again, how do we get the average or the mean? We will just add all the data divided by how many participants. The sum of this divided by 6 is 16 kilograms. So that will be the mean. And if we will mark this on our graph, you will see that the data is dispersed with respect to the mean, right? Some of the data are close to the mean and others are far away from the mean. So that is the purpose of variance and standard deviation. We will create a representation, a graphical representation, how close or how dispersed the data from the average. Okay? So how do we compute for the variance and standard deviation? So what is variance? Variance is the average of the squared difference from the mean. What do you mean by that? And why do we have to do that? If we will get the relationship of each data from the mean, we will subtract, right? We will subtract the raw data from the mean so that we can get the relationship, how far. And by doing that, we will create like this one. The X represents the raw data and mu is the average. If we subtract the raw data from the average, again, what is the average? 16 kilograms. For example, the first raw data is 10. Okay, 10 kilograms. So 10 kilograms minus 16 kilograms, we will get a negative answer. The purpose of the variance is eliminate the negative value. Okay, so we will eliminate the negative value by getting its square. Does that make sense? Okay, so to eliminate the negative value, we will get the square of that negative value. So that is the purpose of the variance. It is so raw data minus the mean squared. Okay? Then you will get the average of this, yung raw data minus mean. So you will get the average of that. So later we will do that. Okay, so let's get first each raw data. So here's the example. 10 minus 16 is negative 6. So to eliminate negative 6, yeah, negative 4, negative 3. So we have negative value. So to eliminate that, we will get the square. So not only those negative numbers, we will also square the other positive values, positive data after subtracting to the mean. So here's the squared value, 36, 16, 9, 1, 16, and 64. Again, we will get the summation of this. So the sum of this, the total is 142. Then we will divide. So we will average this. But if you will notice, instead of dividing it by 6, we only divide it by 5. Because in statistics, if the data is just a sample, again, what is a sample versus the population? So sample is just part of the population. So these 6 dogs, the weight of the 6 dogs are just a sample of the population of dogs. Okay, so 142 divided by 5 is 28.4. So what is 28.4? It is the variance of our data or our statistics. Now, the variance in interpreting this to the normal distribution graph or table or the bell curve, it will be difficult because this is in squared. 28.4 variance is in squared form. So convert this into or to variance into linear form or raised to 1 degree, first degree, not in the second degree. So that is the purpose of the standard deviation. Okay, so we will compute for the standard deviation. So the standard deviation is the square root of the variance. Again, what is the purpose? Why do we have to get the standard deviation? To have the linear form or the first degree of the variance. Okay? So that we convert this or we can put this into the bell curve. Okay, so that is the process of getting the standard deviation or 5.3, approximately 5.3. That is the standard deviation. So as I have said earlier, we will put this into our bell curve or the normal distribution graph. So at the middle of our bell curve or normal distribution graph, we will have the mean, and our mean or the mu is 16. So where did 10.7 and 21.3 came from? So because 16 is the middle, so going to the left, we will subtract the standard deviation. Okay, so we will subtract the standard deviation. And going to the right of our mean, we will add the standard deviation. Okay, going to the left, we will subtract the standard deviation. And going to the right, we will add the standard deviation. Again, what is the standard deviation? 5.3. So 16 minus 5.3 is 10.7. 10.7 minus 5.3 is 5.4. And so on. Okay, so that is 2 standard deviation away from the mean, going to the left. And going to the right, 1 standard deviation is 21.3. 2 standard deviation is 26.6. Clear? So if we were going to analyze our raw data 10, 12, 13, 17, 20, and 24, those data are concentrated in the middle of our bell curve. So therefore, this 10, 12, 13, 17, 20, 24 kilograms of dogs are in the normal or the at the average weight of dogs. Okay, so it's not dispersed. The data is not dispersed. So why did we subtract 1 from the total raw data? Because we follow the Bessel's correction. So when we get the variance of a sample, we must subtract 1. But if we're going to get the variance of the population, we don't have to subtract 1 to the raw data or the sample size. So that is the end of our review. So we will proceed to the mean of discrete random variables. So the mean of a discrete random variables by utilizing probabilities from its dispersion. As so number one, the mean is considered as a measure of the central location of a random variable. It is weighted average of the values that random variable x can take with weights provided by the probability distribution. Number two, the expected value or the mean value of a discrete random variable x can be computed by first multiplying each possible x value by probability of observing that the value and then adding the resulting quantities. By comparison to our review of getting the average or getting the mean. Okay, so in getting the mean, you will add all the raw data divided by the total, divided by the sample size, right? Here, in getting the mean of discrete random variable, you will just multiply each possible x by its probability. Example, this will be the formula. So mu x or the mean of the discrete random variable x is equal to the raw data times so let's say the raw data is x1, raw data 1, okay, times the probability of that raw data, okay, 1. So plus raw data 2 times the probability of the raw data 2 plus raw data 3 times the probability of that raw data 3, and so on. X of n times p, the probability of x of n. So after getting that, the product, okay, so after multiplying the raw data and the probability, you will get the summation. You will get the total. No need to divide. It will be the mean of the discrete random variable. Questions? So again, if you have questions, you can put it in our exit pass. Example, so construct a probability distribution for rolling a single die. Find the expected value. Okay, so expected value means the mean of the random variable, discrete random variable. So here is the discrete random variable table rolling a single die. Okay, so each side will have a probability of 1 over 6. So again, the mean of this, you can get the mean of this by the random variable x1 times the probability, okay, plus x2 times the probability, and so on. Yeah, so we have 1 times 1 over 6 plus 2, each die 1, 2, 3, 4, 5, 6 times the probability of each is 1 over 6. Okay, then if you will total that, you will have 3.5. So that is our expected value or the mean of the discrete random variable. Okay, so what is discrete uniform distribution? So discrete uniform distribution exists when we have a uniform probability. So like this one, 1 over 6. So we will create a bar graph like this one. So the height of this, okay, so the horizontal part is your x value, and the vertical part is your y value. So you will create a bar graph 1, 2, 3, 4, 5, 6, right? That is your expected outcome. 1, 2, 3, 4, 5, 6. So that is the sides of the dice. Then 1 over 6 is the probability. So all of them has a uniform distribution. So if you want to compute using discrete uniform distribution, just get the sum of the first and the second on each part. Right, so we have three parts here, 4, 7, and 10. So the total of that is 21 divided by 6. The average of this is 3.5. So how do we compute for variance of a random variable of a probability distribution? So in getting the variance, of course, we will have to square the raw data. If we will going to interpret this formula in getting the variance of a random variable of a probability distribution, first get the square of the raw data, then multiply it to the probability, get the sum of that, the total of that, minus the square of the mean. Of course, after getting that, the variance, you can get the standard deviation. And the standard deviation of a random variable of a probability distribution is, again, it is the square root of the variance. So let's use again the previous table, or the rolling a one-sided die. We already computed the mean of that random variable. Okay, so the mean is 3.5. So let's compute for the variance. Okay, getting the square and getting the sum of that. Square of each random variable times the probability, then get the total. Okay, so after getting the total, we will subtract it to the square of the mean. Okay, so 15.17 minus 12.25. The answer, the variance is 2.92. Okay, again, we cannot the variance in terms of the normal distribution graph or the bell curve. So we must get the standard deviation. So in getting the standard deviation, we will just get the root of the variance. So the root of the variance, or the square root of the variance, is 1.71. Normal distribution graph. So let's interpret the rolling of die. So let's interpret the rolling of die using the normal distribution graph, or the bell curve. So the mean is 3.5 and the standard deviation is 1.71. The shaded part, so the shaded part of the normal distribution graph is the one standard deviation away from the mean. Okay, so the mean is 3.5, the standard deviation is 1.71. So at the left of our mean, we will subtract 1.71, and at the right of our mean, we will add 1.71. So it means the odds, or the probability of getting value. So again, the sides of the dice of a die is 1, 2, 3, 4, 5, 6. In average, it is between 1.79 to 5.21. So you will roll the dice with a high probability. Yeah, so almost 2 and 2 to 5. It is between 2 to 5. So do you have any questions? So you will put it in our Google Classroom evaluation. I mean, if you have any questions, so put it in our evaluation, Google Forms evaluation. So that's all for today. I hope you have a good day today. Goodbye. Thank you.